Okay, making sure everybody's, so it is recording now, so we're gonna start a discussion with Alton, Jensen, myself, Nick when he gets back, and mostly around Spark.
And I'm just gonna say Happy New Year.
Yeah,
Anybody said no?
if you have any more last minute items, you missed it.
Wow,
So what if we just start with, why don't we do a few basic questions on Spark? What do you look for first for training or for knowledge? I sent around to my team some different Spark links and stuff. Do you know of any good ones that you like? Or
so I absolutely just followed the tutorials on Spark. I mean, they're fantastic. They've got the videos, and then all the Spark conferences have
they're all
recorded.
Yeah, we found that too. That if you go search on YouTube, there's actually a Spark subscribe you can subscribe to, and you can literally subscribe to like the Spark conference, so you get the whole thing basically right there on YouTube.
That's intense.
Yeah, that's
It is
actually.
It's great. And so I was there at the conference and got a lot out of it, but I think you can get as much as you want out of it too, just by
Forward that email.
just by watching.
Okay.
Yeah, so I mean they've shuffled things around, but here in the latest release, just go through the programming guides, quick start, and just have at it. Install it locally and just start going.
I went with the Hortonworks sandbox. Did you do that, or did you do like a local instance?
Well, yeah, it depends on what resources you're using. For personal use, I've always done just the standalone install because it takes up less resources, and then I can maximize my memory and just my computer, and really all that I have installed on them. So let's say I have about 8 nodes now at home, but they're all smaller, like 16 to 32 gigs each. Right, because they're just commodity hardware, not like sort of enterprise grade. Anyways, but so I use standalone, and then I also have H2O running on those, which works pretty good, and then just HDFS, right?
Yeah.
So it's
Are you guys
pretty
using
neat.
No. Describe, what do you mean by H2O?
Yeah, H2O is another project for machine learning.
Okay,
Let's just go there real quick.
Or not? Okay.
Hello.
This is
Morning, Joe.
How are you?
So what I like about H2O is that it treats R as a first-class citizen. So so you can integrate very seamlessly with R and scale out from using similar R commands and just loading the library and then accessing your cluster of machines, each one running H2O on it. So man, they've changed this up too, but
How do you, what is the connector? Is it out of our studio? Is it?
oh yeah, straight out of our studio. Yeah.
And another thing I'll mention too that I like when you say you run it locally, that's the cool thing about Spark too, is you can play around completely locally.
Oh yeah.
Get the power and the speed, everything on your laptop, literally, and you don't really have to have a cluster until you go further with it.
Yeah.
You can kind of keep it on there independent. For me, we're planning production uses of it, and so we kind of went straight to the cluster. We actually had an AWS cluster already set up.
Oh yeah.
And then we just kept deving inside there. So we put Spark on there, we put it in as a cluster, and we just started going with the tab.
Oh,
We
exactly.
didn't bother, because our RTL was all designed inside there anyways, so there was no reason to do the local. So,
Oh yeah. Exactly.
local-
Standalone.
Yeah, the standalone's really nice if you're doing your own project or something. It's
Exactly.
perfect. Yeah.
And it's lightweight. Yeah. So, yeah, and then you brought up Hortonworks. I would, Hortonworks is great. I definitely would use them for any of my enterprise grade installations.
On the other trainings too, the other ones that I sent out, Hortonworks has a few getting started with Apache Spark. that you can use the sandbox for. Like I said, they do great tutorials with their sandbox. It's really nice. And then Pluralsight has one course as well on Spark if you've got a Pluralsight subscription, but only one. And I wouldn't say it's extensive. It's much more getting started and stuff. So they don't have a ton out there. If anybody wants to make a Spark course, great idea.
Yeah, seriously.
But it doesn't, there's not much out there right now for it.
So this diagram actually is almost exactly what my cluster at home looks like. And 4 of the machines are laptops, and I thought about bringing them in, but we're actually not going to get that far to play around with it today. But so basically, underneath you can have HDFS or raw data files just to distribute your larger data sets, and then you can have Spark on each one of your machines, your executor, your JVM executor, and then also on concurrently running on each one of those machines is H2O, and then this kind of represents that the RDDs and the data frames being passed back and forth, and the machine learning being done within the H2O framework.
So is HDO just bringing the cluster together? Is that kind of what it's doing? Am I right there or no?
No, H2O is a collection of machine learning algorithms,
Okay, I see.
just like MLlib.
I see. Spark does something to it, hands it off to HDO.
Yeah, it's like
HDO
data
does the
handling.
machine
Yeah,
learning.
exactly.
Thank you. That makes it clear.
Yeah, that's a good way of putting it.
Okay.
And then let's see if I can stumble across an example. No, let's get, this is deviating a little bit. So that's kind of the realm that I'm playing right now. So in fact, right now I work for MR McCann. We're a marketing agency, and we're the agency of record for Cisco, among my other global clients. But it's kind of a big deal. Cisco is a big account, and in fact, they're a big user of H2O as well. So a lot of what we do is like campaign analysis and modeling and forecasting the impact of marketing efforts and different types of content and audiences, and segmenting those. And then the scoring comes into play when a user goes down as, a journey, like they get an email and then there's some call to action, and they land on the website and start to engage with different content, or they go to a webinar or meet up at some event. All this contributes to a lead score, and they're scored on different types of technologies, as well as their willingness and a readiness to buy, right? So you can read more about them. I think the use case is pretty well documented somewhere in here.
Do you get kind of the same campaigns over and over again, or is the schema changing, your data changing? What's coming through?
People are changing. I mean, they're yeah, of course the campaigns are changing, and how they're structured, and the content itself changes, but but also people's behavior and how they're consuming it, and their journeys.
And does that change more on time, more on who the client is? Cisco's customers are probably very, very different than Nike's customers, right?
Oh yeah, absolutely. Yeah, a little both. Yeah, and over time.
Does it give you an aggregate profile of the company that they're buying for, as well as the individual consumer? Does it provide any type of breakout like that as well?
Yeah, that's a really good point. So we do models at the what we call account based, so that we're marketing to the company and kind of understanding the company as a whole and all the individual users within that company. But then we also look at the individual and like the CTO or the CIO of that company, and as an individual, how are they consuming and behaving? And yeah, so you kind of have to look at both granulators. Is that what you're talking about?
Yeah. They can shorten your buying stream because you can get to the decision maker quicker.
Oh, you absolutely do, yeah. And you get a better sense at the account level of kind of holistic view of, that company, and and the dynamics and how things are happening. So for example, you'll see like somebody register for a white paper, but then they really don't do anything else. But then there's a lot of other activity among other individuals within that company.
Are you tracking people outside of one step, like within a system? So let's say somebody looks at a white paper on Cisco, and they look at the white paper.
Oh yeah, there's third-party data sets that you can subscribe to, but this is mainly on site. Yeah. So great. So that's H2O. That's how it interfaces a little bit, and a little bit with Spark. Now I want to tell you a little bit of my personal motivation. So I want to just spend a couple minutes on this real quick. I've got a landing page that I set up. Let's just go here. Frontanalysis.com. And my goal here is what I want to do is create a product and a service for people to come with their data and kind of be able to just dump it in and get back some feedback, get back something meaningful real quick. So let's just skim down to examples. I've got 2 examples that I put on. This one, Blast Off Toys Inc. This is a PDF that I actually took from a competitor who's doing something very similar. And to give them credit, they are narrative science, where basically you can do the same thing. You give them a data set and they turn it into a narrative, into a story. And basically all you do is give them the CSV and they generate this text using their proprietary natural language generation. And it writes the sentences and it includes the most relevant plots. And in this case, it's a multi-channel performance report, marketing report over some time period. And it makes it very human readable and consumable, and so that you can scan and kind of breaks it down to that level where now it's actionable, right? And I can say, oh, wow, we're down 13%, or we're down 57%. That's a big deal, right? For those decision makers. Whereas when you look at the raw data, it's sometimes not very consumable. So I want to give them credit because they're a much larger team, hundreds of individuals working on this. And I literally just ripped them off right there, but that's okay. Eventually that'll be mine. But to make it a little more concrete, I'll give you a couple other examples. Say, for example, you are shopping for a car and you want to take all of the recent sales history data, and if you could get your hands on that CSV and dump it in, it'd be nice to have it just tell you, in plain English, am I getting a good deal on my next car? Or same with a house. Or and then they in fact list a lot of other industries like medicine, where if you have a family member that's in the hospital, it'd be great to just consume the data about that patient and then in plain English say, how is the patient doing? Are they getting better than they were yesterday? Somebody's in the NICU, are they, just tell it to me. Tell me the facts, but also tell me what's valuable and important. So obviously a big consumer of data is financial data. And so this is my plug here for my little pet project that I'm working on. And it really ties in a lot of what I've been doing and kind of the apex of where I'm headed. So take for example, financial data, and here's an example of some demo data that you might be able to get online. So this is just ticker information in the company, the local price, shares, and then you have something like its market weight, and some other information, right? Too. So there's a lot of stuff going on here, but at the end of the day, what would be nice is all this leads to this. sector summary. So right now, this is telling me the energy sector is up percentage-wise, and everything else is down, probably down or flat for the year. But within this, so we had the sectors in that data set, but we also have the different companies too. So it'd be great to know, like, what's driving energy. Is it the oil price change? Is it just one stock? And so taking all this data and loading it in here, so literally you can just come in here to my tool and you can pick the top companies and you can upload and analyze now. And that uploads to my S3 bucket. And then you have to fill out this information so that it actually
Sends you something.
yeah, so it actually, so it'll send it back, right?
That's just for you.
Exactly. And so this is working in the background, and I literally did this like last night at midnight. So
Attaboy.
I know, seriously. I think that's all that's required. Okay. Okay, so that's running. Now, and then what literally comes back is, oops, that's my notice that it's running. Okay. Then what literally comes back is the insights. But more than like my competitor just taking it to the marketing, to this PDF, I want to push it all the way to video so that you can just sit back and eventually what I think would be great is to tie this into VR so that you could just sit back and you could just be like freaking exploring your own world and just data is streaming in and now you're in this like, but let's just start with video. And basically what happens is that, bear with me on this one. This is a much older version of it, but it'll give you the sense. So actually, maybe I need to preface it a little bit. So one of my use cases is to run this just daily or on my my algorithmic trading, my automatic signals that I have that are running on my Spark cluster. And some of them aren't good enough to trade on, but they're still interesting. Like they're telling a story about what's happening for the day. And I want to dump those straight into YouTube and just generate ad revenue. Okay. So that's one of these versions. So that's why it's got this this interesting header or this intro. And then in this case, this again was an earlier version. So all I did was type in McDonald's and it created all the video. And if you can hear, it looks like the sound's coming through on the.
I'll be coming through on the HDMI.
Hang on, let me turn it up here.
It's not the speaker, sorry.
You might want to mute that.
Most people enjoy that sound.
Okay,
They've been watching like one track again.
okay, yeah. If you watch it on the site, what you'll see too is that here, let's click on this next link real quick. Yeah, I'm a little bit deviating, but this is exciting for me. This is what I'm passionate about. So that CSV in the background, on my cluster at home, it's and a little bit on Amazon. It's generating this text just like that my competitor, and it's turning it into literally human readable the insights and what you care about. This gets fed into a screen reader. And that's why I said this is one of my earlier versions. So this text gets read on here in this somewhat robotic voice right now, but there are other voices that are much prettier, like Siri and such that some are proprietary, but there's actually decent open source ones that I'm already using.
But you're creating a rich media re-rendering of the information.
From a CSV with no additional human input. Yeah.
Can I pose a problem for you?
Oh, sure. There's lots of problems
over the
with it.
next year, hypothetically, we're going to be opening opportunity hubs, which are spaces like the holodeck that will have 3 to 4 types of employees in ultra-rural communities. Some of these will be as small as 25. Some of these will be as big as 75 employees, contractors, occupants of these facilities. We also know that we have accessibility to Drew Mingle's data from the state with the open data, which could serve as the rock or the CSV,
Mhm.
which we could then be in real time putting information in and showing how much of an effect we could have with the CMP, the county.
Exactly. Yeah, that's a good example. Yeah.
So something like that, it would be ongoing cron. That,
Oh, of course,
That
yeah.
could basically have any type of performance. For me as a proprietor, I can then go to the clients that I'm working with and show where there's a better propensity for in a cold country, as an example, we might have a better type of profile of people that are coming out there versus if we're in cow country.
Yep.
Or something that's
Yeah, that's a good example. And the presentation becomes more of like a rich media experience than just plots and graphs. I mean, of course, there'll always be that element too, but
the human capital data
Yeah.
points could basically be the same type of measurement that you're talking
yeah. And another example is, so you already see this kind of happening. Like when I went to Disney World this year, there are certain rides that you ride, and instead of just taking a picture of you, it takes a video. Okay. And then what they do is they upload that to their website, and they get you to try to buy it, right? But what it is it's a personalized video of you intermingled with like the characters, and like it becomes like a little snippet just for you, just for your family, just for, and that same thing happens like on if you use Google Photos or if you use Facebook, right? Especially this time of year, at the end of the year, they just summarize it and they kind of just tell you a rich media experience, but that is just for you. So it's a little bit opposite of like, a movie experience where we're all watching Star Wars. That's one experience
That was
for the masses, but sure, just for you, yeah. $1 billion, yeah, sure.
Yeah.
And production, but instead this is like how efficient can we get that single that single rich media experience, and even one that like might only live for a day. Like my stock example, nobody's going to care to go back and watch, from a month ago, how that particular day was performing. They'll just grab the data and at best case scenario, they'll just regenerate the video, right?
But you might even have an issue in this case with like customer service themselves data.
Exactly.
You actually have facial capture where you can use biometrics to know the individuals that are doing this and shoot way down the road.
Oh, sure.
As
Yeah,
like
more of like a
voice samples
VR.
and stuff like that.
Exactly. Yeah.
Cool.
So
I'll shut up now.
So that's where I'm really passionate and excited. So there's a lot of different pieces that are coming to play. I wanted to next kind of steer. So anyways, you're welcome to come here and play around with the upload, and assuming things don't break, it'll get back a video to you. Let's see, but for now, I wanted to change gears because along the same lines, I've been spending some time on Kaggle, and if you haven't played with Kaggle, it's pretty fun. I haven't done it as much as I've wanted to, but it's pretty neat. There's at the lowest level, there's getting starting exercises where you can do like for example the Mints data set and recognize characters. The Titanic. I mean, these are just classic data sets to play around with, just to kind of gain exposure and get familiarity with the diversity of problems. But what's neat too is they have these active competitions that actually pay out decent amounts of money. None of which I've won yet, but I'm working on it. And what is fun too about this is it gives you a data set and a problem to work on and collaborate with individuals that are outside of maybe like work, where you might have to be a little bit more proprietary or kind of a little bit tight-lipped about exact methods that you're using. But we're here, for example, the Wimbledon Stock Data Challenge, you can come and download this data set. They're motivated also by trying to find candidates that will eventually work for them. So that's what they're trying to explain here. But as far as data goes, I wanted to shift gears, and this kind of gives you a real example of where I'm headed and how this applies. And I thought, depending on on the level of interest of you guys here in the room, we could go in as deep as you want, but I was planning on running some code, and we'll see how much you want to do. So here you can download a training data set, and they actually split out a test data set for you. The training data set will have, it has the factor, the features that you can build your model on, but then it also has the responses, right? That's what you're training on. The test data set, that's what you don't know what your responses are. All you have are the features, and so then you build that model and then you submit it, and they give you a sample of a submission. This sample submission is just assuming everything is zeros, I believe, and then you get scored on that, what you don't know, right? So so this particular data set, this is what it looks like. They are giving us the previous day's return on 40,000 stocks or time periods of the same stock. We don't really know. So the day -2, day -1, and then that day's return. But that day's return is split out into intraday. So we have, I think it's every 10 minutes maybe. Some 10-minute intervals throughout the day, and then right in the middle of the day, you have to make your prediction about how the rest of the day is going to perform for all 10-minute intervals, and then the next days, and then the following days. Okay. So actually, I'd like to write on the board. Oh my gosh, is that seriously all we've got?
We got all these windows.
Maybe I should.
If you need more colors, I got pens in other
Yeah,
rooms.
Let me just get one of these.
Feel free to use windows.
Yeah. Maybe this is. But tell me if this is not the direction you guys want to go. But okay. So now, so you get that. Yeah, this kind of makes sense. In addition to, the known performance up to that point in time, they're also giving you 25 features. Okay, they don't say what these features are. They just are features, right? And I'd assume some of them are just random noise. Some of them actually mean something, right? So okay, so how do I start this? So let's just get in here. Are there any questions actually up to this point what this kind of looks like, this challenge? But maybe looking at the data will help a little bit.
It was a Kaggle one, right?
Oh yeah, this is Kaggle, yeah. So I've already loaded, this is R Studio. This is just an IDE for interacting with the R console and the R programming language. And very similarly, I could use another IDE like Juniper or IPython, like Ben was using yesterday. This is just what I'm comfortable with, and there's a lot of features that I like about it. Up here at the top, highlighted in blue, is some code I've already written, but down here in the console, I can still interact with R, and I can do, whatever, R can do, and I can interact with it. And so what I'm looking at here is just the top 5 rows of the, or 6 rows of the training data set that they gave us to download. So each row has an ID, and then this is what I'm saying. There's 25 features that have different data values within them. Okay, just that's they could be, for example, this could represent something that's categorical, like maybe this means what sector it's in. Is it energy? Is it tech? Is it right? This numeric one might mean something to them, like what's the risk that they want to apply to it, or like what's the weight of how much it's been tweeted. Is there positive or negative sentiment towards it? Maybe this one, this positive, negative. So we don't know what those features are, but you can kind of imagine in your own mind that you have just a set of features.
But they don't get it to you at all. So you can't go in and do manual feature engineering.
Not
This data set.
not beyond this. There actually is some that we'll talk about. Yeah, because you can take, for example, take any two features and multiply them together,
Mhm.
and you'll get you kind of get a a derivative, a new. You can engineer features a little bit that way.
Okay.
But yeah, you can't go augment, right? Because we don't know what stock this is. We don't know what day, so it's kind of nice that in that way, right? You can't win by trying to expand the data. Yeah. Okay, so and then like we said, now we have the return. So okay, let's just pause there for a second. Let me just write this down. So if we have, let's call those responses. Actually, let's just. Oh shoot! I don't know if I want to bias this yet. I'm trying to think about how I want to. Well, tell me real quick, since this is a discussion, how would you approach this? Do we have any?
To get the previous. In other words, we're getting an incremental previous compared to all these features, correct?
Yeah, and we're trying to predict the return starting at. So we have intraday returns up to here, up to 81. Up to 80. We know all those, but then from here on out, we have to predict, using all this information, predict 81, also predict 82, predict 83, 84, 85. Okay. Here's what we'll do. Before I start biasing, because I don't want to tell you my solution without brainstorming a little bit, or at least, maybe you don't have any ideas, but I could lead you down a brainstorming path. And okay. Let's do a little bit of feature analysis. So I've already done this a little bit. So so this is selecting all the features. One of the things that's interesting and a really big challenge is you see right away all these missing values, right? So here in the 25 features, I'm just listing the top 6 rows again of the 40,000. We have missing values. So that means, if for this one, for example, we don't know if this was the sentiment, right? We don't know what the Twitter sentiment for this one was for this 5-day period, right? Or for another one, we might not know what what the rating was for the analysts, or there's this missing data, and what do you do with that? That is a little bit of how the art side of it, right? Do you just put zeros in? And depending on the algorithm, because some algorithms can handle missing values, and others, would you put in the median, or would you put in the average value, right?
Or try to predict it from other features.
Yeah, or try to predict it first and do like a 2-step. Exactly, absolutely.
What do you do when you get a null exception error and you can't, and your algorithm doesn't allow for it?
Just whenever you take a break, go on a
Throw
walk.
in a towel and go to the next one.
Yeah, that's the cool thing about Kaggle, right?
Data cleansing.
No, I mean,
And tell your ETL people to fix it.
yeah, you'll kind of see that in my approach as if we get through that. I'm already burning a lot of time fast, but as we do this, you'll see that I like to take steps and prove myself along the way that it's working right, and that we're thinking along the right path. But here, let's look at a few of these.
I think one of the things I would try to do is predict the first 10 minute, and then try to use those in the data sets to predict the next one.
Exactly.
Right.
Oh yeah, and just kind of do like a moving forward in time. That's a great example.
So that average basically becomes the fixed variable that you have in place until you get new information as well.
Yeah, the first 10 minute, then sort of the feature of the second 10 minute.
Exactly. And I'm really glad you brought that one up, because that's an awesome example. Yeah, that will have some influence on the type of model that you can choose and how you want to approach it, right? Or at least your process, because certain models you have to run for that fixed time, then move out your windows, right?
Yeah.
So also just looking at some of the data I mentioned, there might be categorical. So this certainly looks categorical. What about some of these others? where this one, for example, it's a little bit more evenly distributed. Along the bottom, this is a table, so it's tabulating it's a crosstab. It's counting all the number ones, all the number twos, and so forth. We see also, but what about this one, where this feature number 9 is again the top 4. So see how it looks. Is that categorical? Meaning, does group 11 have any relation to group 10, or is it ordered? Is group 10, does that truly come out, after 9 and before 11? And is it like a true integer? Is it continuous? Is the difference between a 9 and a 10 the same as the difference between a 10 and 11?
Or is it logarithmic or something?
Yeah, and so all these things, you have to kind of, these will play into, how you approach it. This one's kind of interesting because as you tabulate it, look at that, how you see a lot of large numbers, but if we plot it, look at how it's normally distributed. My guess is this one's probably a fake. They probably just generated that. A little too normal for me, but but I mean, this happens all the time. I mean, the normal distribution is the normal distribution because it's normal.
I don't know. See, to me, that graph is a perfect estimate of, say, something busy during the day. In other words, that's exactly what a server looks like when it's busy.
Oh,
So
absolutely.
you do those
Exactly.
hours.
Yep.
You basically stop at 5 o'clock. So whatever that was, it stopped from 7.
Well, it could
back to
be.
work
Could be
day.
trading.
Except we're
volume.
going to 29, but yeah.
No, that's my point. That's a work day if somebody cuts off, if somebody starts at 8 to 5 to me.
Oh, yep. Yeah,
That's
a
an
good
exact
example.
work day.
Yeah.
Whatever that feature is.
So I mentioned missingness. If I tally these up, this is just a custom function for counting the number of missings within each column. I apply that to the whole data set, and I get as a percentage. For example, feature 5 is not missing any values, and neither is 7. But for example, feature 1, we've got 80% are missing.
Yeah.
That poses a problem for certain types of algorithms. And how are you going to approach that? There certainly probably is information in feature 1 that'll help you predict the future, but it's going to depend on how you handle it.
Does that potentially mean that some things of that are created later too?
It could be. Oh yeah. And that the data was just unknown and missing for before because now we just started getting that feature, right?
Did the competition did it say we have to predict each feature, or we're just predicting
Oh no, we're
the
predicting
numbers for all
responses.
25 features moving
Of
forward?
every 10-minute increment afterwards.
Yeah.
So you have to say.
So
'Cause I was
let's
going to say, could you just say we cannot predict feature 1 because we do not have all the data related?
oh yeah.
In other words, could it be one that you have to take out?
Yeah, that's okay. So you're bringing up a different hang on. Let's
Keep
solve
going.
this. So these features were provided as kind of identifiable and known inputs that we can use to predict what we want to predict in the future. But like you mentioned, there could be a scenario where you want to not just take the average or not just throw out the missings or set them to 0, but you might want to use what you already know about everything else to kind of predict, like do one step predict, and then use that prediction to predict the next. And that certainly can happen.
Another thing that might be interesting is to correlate. I mean, some of the ones that you view as potentially categorical, right? Try to match them up against something like feature 1 and see, well, maybe the 83% is because feature 1 only applies to things that are in category 11 and 13. I mean, like if it's a specific set of data for those sectors,
Oh yeah,
right? So
exactly. It's like a
they're there to
subset.
help you normalize those sectors.
Yeah, within that. That's true.
Or something like that.
Yeah, that's a very good point. So it's yeah, exactly. It's yeah, there are different ways of analyzing. Yeah, doing some feature analysis in there would absolutely help. So now we're going to look at the responses that they've given us. So this is this first dot right here. This is if I invested in this on day 1. Well, before day 1, I wouldn't have any return. By the end of the day 1, I would have this much, and then by the end of, hang on, sorry, this would be day 2, or if we considered this D0, day, then this would be day -1, day -2. Okay, anyways,
Those are the-
and then this is the intraday every 10 minutes, right? And we have this known up to this line right here. And then what we're trying to do is use all the information here as well as the 25 features to do this prediction through time. And then not just that, but get the end of the days right for the next 2 days. Yeah, tough problem. I mean, get this right and you'll be a billionaire in
Right.
3 days.
Done. Let's do it.
I know, exactly. Let's do it, right?
Let's turn the button.
And that's exactly what they're doing. I
Your
mean,
New Year's Eve plans.
yeah, exactly.
Kind of
Okay.
the subplot of that movie that's out right now. I can't remember what it's called.
So they start with the plan, giving you days, and then now a 10-minute increment, but they
Yeah.
no 10-minute increments in those.
Oh, no, there's a
those are
few.
more granular.
There's a
The
few
first
10 minutes.
In
Yeah,
the first
leading
2
up
days?
to it. Yeah.
Okay.
No, oh no. In the first 2 days, no, there's no 10 minutes.
Just full day.
It's just full
And
days.
then they give you nothing past that 80th time increment. You don't get anything. for the
No,
future.
you get no
Okay.
future feedback. Any of this, all of this, you need to predict. So I really like your idea. One is, could we just predict a little bit out? Can we just predict like maybe 10 minutes into the future, 20 minutes, right? And then use that, and then kind of do the same thing and keep moving forward.
And see if there's any patterns in the.
Yeah, and let it-
10 minutes. that-
Yeah, let it kind of propagate and let it kind of tell me where I should keep going, right? There's absolutely that.
That is a lot more, I mean, less traditional than what Ben would kind of talk about yesterday. So when we take all the previous data, look at it, get a training set from it.
Yeah.
And then work from there. You're talking about take a very small segment of the data, use that to try to predict, and then move forward based off of that.
Yeah, it's taking a piece of the pie out and saying, can I predict that?
Which makes a lot more sense than a thing like a volatile market like a stock market or something, because then you have much more.
Well, yeah, and the difference is, well, we're not dealing with images or audio. This is it. What we're predicting is a linear response. We're not categorizing, right? I mean, you could do it like, hey, is this stock going to be positive or negative? Categorical. Sure, there's that. But we're trying to find, like, what's return going to be at 10 minutes,
Right.
right?
Now, another thing to point out though is the 25 features are the 25 features. There are no
They're not
options for other.
Not in this
features
data set.
Later.
Yeah.
So one, you couldn't translate this directly into the real stock market, but two, we should be thinking about.
Oh, well,
that
you
as-
could add more features in your model. That's no big deal. But
Well, it is a big deal when you're talking about the stock market because then there are 2,500 features for every 10-minute increment, right?
yes,
Something said something on the news and that.
Yes.
everything.
Okay. yeah. Now you bring up a really good point too, because exactly something was said. Now I've got to go take my entire data set and shove that all to my GPU cluster and do like this massive, neural net.
Yeah.
Just so that I can get back my huge model that's going to be like 2 gigs or whatever and load it in and then send the data through. But then like
They've already
futures
said
already
something
changed. Yeah, it's already done.
Yeah.
Right.
Oh, sorry, that was wrong.
Right. And I think that's another example why the type of model that you're going to want to choose here is going to be one that's a little more adaptive.
Uh-huh.
And a good example is if you are on Yahoo or like on Google News and it says, oh, here's the articles that are interesting to you. Well, how does it know? It's like constantly knowing. Well, it's already kind of adapted to me and the individual. And there's only so many personality types, right? I mean, that they're going to model. Even if it's a million, it's still a fixed number, but it's not going to be, it's going to be 1,000, if that. So you have all these personality types. That's one thing. So maybe think of those as features, and maybe I'm deviating a little bit, but then you have these new articles though that are coming in, right? And while you have new articles, you also have people's feedback, and so you present it to a few of the individuals that you thought should consume it. Maybe you don't get the response that you did, so that kind of depresses it, and your model needs to adapt. But the difference is that the world and the universe doesn't change that much from one instance to another, right? There might be a really big story that comes in through the pipe, but the way that you react to it isn't going to change that much from how you would have reacted to it like a minute ago, right? So your model is like just slowly adapting.
Yeah. So is there something in this feature set where one of those features is more of a constant than others? Can we see that relatively?
Oh, no doubt. Yeah, there probably are, but I
Well,
don't have
feature
that
one
one.
doesn't have anything, so that's pretty constant.
No, but you're right.
But
Yes.
you bring up that great point too. If you took this same iterative approach that you were just talking about, let's only predict 10 minutes. Let's only take that sequence. What if we also just said features are profiles? In other words, we're not going to predict every feature. We're going to predict one feature, and then we're trying to predict another one or two features together as a set to kind of treat those features as here are humans or are people that are being impacted by something else.
Yeah.
Then you can start to predict them very, very quickly. And you can only predict that set. So maybe you can't predict all 25, but you can predict one person if he has set up enough right things, then you can predict that piece.
Yeah.
So
Exactly.
you limit yourself down again.
Exactly.
And again, that
Get the ones you
doesn't win
can.
the competition.
And there's going to be lots of outliers, but so one of the problems we have though about setting it up this way and thinking of it iteratively, and so I just kind of explained how if you can imagine modeling the world, it doesn't change that much from the next minute, but it changes a little bit. So you want to adapt, and you keep adapting your model and so forth. But the problem with this data set is we don't know, like, if one of those 25 features changed after 10 minutes, right? All we have is really just before and after. So what would be nice? Yeah, what would be nice is if you were building that type of data set and wanted to model it that way, you would actually have. You'd have row,
You'd have more coming into your features.
yeah. So I would know that row ID number 1 is the same as number 2, except this is just like a 10-minute later snapshot, right? You'd have like a, and then maybe all the features are the same, except maybe one of them changed, or maybe some value changed a little bit. And so really all we're changing is, we're just adding in the new returns, the next few returns, which can be valuable, right? But okay, so now that we're consuming this and starting to really think about the nuances, take a look at this one, for example, where things are humming along, but then just boom, right after when we need to predict, we just have this drop, right, where it was relatively flat during you can't even really tell that line's even flat there.
So this represents the training set, right? This is where we have the actual results that we're trying to predict.
Yeah, so we know all this up to the blue dotted line. So during the day, it's kind of flat, but then down, right? But that's okay. What I'm not showing here are the other 25 features that will hopefully help explain why after this moment in time it dropped, right? And they might have given us a data set, say like during a flash crash, where they know that the flash crash occurred at this time. Can they use the information to predict to know what was going to happen, right? Okay, so I have some different functions that I wrote here in R. One of them is plot n, so I can plot. Basically, it just brings in a list and just loops over each one and plots it just like this. Here I'm just showing one, but if I want to show a random 100 plots, then we have something like this, where, okay, this is kind of what you'd expect. Maybe we have a pretty flat distribution over, random days and random stocks or whatever these products are. But then some are, some go down quite a bit during the first few days, maybe level off, or maybe even some within, like can maybe, actually, who knows? But just imagine, there's going to be some that go all over. In fact, there's going to be some that just take off too. Now what I can do is with this, I really like to do this with my data. I like to be able to visualize it so that you can see what's going on a little bit. And for example, if we take the training set and we take feature 16 and we just look at the values that are labeled 2, right? So there's lots of different labels, 1, 2, 3, 4, 5, and so forth for the feature 16. And I'm just looking at those that are labeled 2. Look at how you can see there's something going on here. For bucket 2, there's definitely this bimodality. The first 2 days, they either went up and did stuff or they went down and did stuff for the most part, right? That type of, that feature that's calling out that behavior ahead of time is the type of stuff that the model will need to pick up on so that it can predict in the future, right? But that was showing what if, through that point in time right at the very beginning, what we really care about is leading into it, right? So I set my function up so that I can look at it this way and say, for that stock, I have this information about it leading up to it. Sure, there's these two different groups, but when they come in, look at how that feature by itself, just looking at group 2, it afterwards, what's it doing? It's still just random noise. It's just wild, right? So that makes sense that you wouldn't be able to just pick one feature and say, oh, that feature describes perfectly a certain behavior. It's going to be this more comprehensive approach. Okay. Now,
But if it's something like industry or something else, you're going to see.
Yeah, maybe moving together. Except that these are different days. We don't know. Maybe one of those features is day. Maybe that one that was 1 through 30. I don't know.
Either way,
it doesn't matter. I mean, they don't tell us, and it doesn't even matter actually, really, because it's just numbers in the end, which is kind of cool. So, so this is how I'd approach this. I know that this is a machine learning problem. So I just go to my machine learning textbook here, and I have all these different problems that I'm working on. And sure, this is great. Clustering, yeah, sure. Dimensionality. We already talked about neural nets. That probably won't work for us right now. Well, it could be fun, and actually, it would work for the. Hang on, it would work probably really good for the competition. But what about that process? What about updating it every second or every 10 minutes, right? Not what I want to do personally, because of my auto video thing, right, that I talked about. And I'd rather have a holistic model that kind of can adapt through time. And then, so let's see. We're definitely doing supervised learning, and we're not doing classification, we're doing regression. Great, so that gets us to this chapter of the old textbook. So let's take this simple little plot here, for example. If our world was this easy, and all we have from basic, 5th grade math or whatever this is, if all we have one response just 10 minutes out, right, is equal to just one feature 16, right, x. And I want to add some weight to that, mx. And then maybe there's some shift, like for example in this one, there's some horizontal shift up. Bam, that's plus b. Boom, look at that. We just did that. Okay, great. Now, kind of biasing this a little bit, and knowing that we're doing regression, and of course we could do transformations to the data first to get logarithmic, and we can do squares, and we can do interaction effects and so forth. But if we're just thinking about one, I'll remind us that there's a closed form solution for this. In regression models, you can use general linear model, bam, solve this linear algebra equation, and that fast you'll get the solution, right? Which is great, but again, that's back to the, well, as my matrix gets larger and larger, as I'm trying to predict more, and I have more and more x's, and my problem expands, so now it's m1 times x1 plus m2 times x2, right?
Yeah.
Plus m and so forth. And this is just predicting the next 10 minutes out. Now we're doing that matrix, not a super big deal actually, even for very large matrices. But it also has to be invertible, right? You have to be able to transpose and invert, and that sometimes can be a problem. Anyways, read the text. So, okay, the next thing is we also want to have our model kind of adapt, like we talked about, right? So that I don't necessarily have to rerun every minute, and do the whole computation. Instead, I'd like to just settle on a solution and then take in new inputs and kind of adapt with it. And while that might not be perfect for this competition, like I said, but it would be good. So that, and also knowing what I know about H2O, knowing what I know about Spark, I'm going to kind of blend it all, and I'll come in here and say, of this universe, of these machine learning library algorithms, which one best suits my solution that I want? And I'll just tell you right now, it's this, stochastic gradient descent. So I'm not doing clustering, I'm not doing collaborative filtering. Well, that's cool. Not for this problem. I certainly could do naive Bayes, and I could do a linear decision. No, I could do linear regression. The ensembles of trees, I can't remember if that has regression in it too, but some of these could work. Underlying most of these, though, is gradient descent anyways. Okay, so let's look at that. Oh, wow, this looks awful. I'm actually just going to leave this for an exercise. Let's get to the fun stuff. This, I also had pulled up another resource, an intro. This I just did one quick search. This was the first one came up. An intro to gradient descent. Same idea where he's trying to fit a line here, y equals mx plus b. And this is just one, right? The next 10 minutes, right? And just using one x variable, one of the 25 that we have. He shows Python code, and here we can go through this example. So when doing gradient search, what we're going to look for is the values of m and b that solve this, right? And we can initialize it with zeros or whatever, just put some random in here. And the next time, it needs to kind of adapt and try to fit better to the data and keep fitting until eventually it fits very well, right? And that's what that gradient search is. So you can imagine now a valley, and that's why they call it gradient, because you're on, well, they use the gradient. Anyway, they use the slope. But imagine you're in a valley, and you start in some random place, but then you can take the derivative, and the derivative will tell you the slope at that location, and then you just take a small step in that, and you keep moving. And that's what this is doing. It's moving in the direction of optimizing and solving the cost function. Okay. So you can also plot your error or your cost, and you can watch it as it diminishes over time. So what this means is, here we could solve this on the board, or we could we'll just look at it intuitively. If you take every data point here in one of these plots, and you subtract you find the difference from what it predicts it should be on the line, and you sum all those up, that's going to give you some error amount, right? And if you imagine that the line is way off, it's not even close, and you're just off, you're going to have a very large error. That's how far off your prediction is from the truth. That's what this is. But as it moves closer and closer to the point that it's splitting all the values, this is least squares regression, right? It's now you're summing it up, and the least, it's trying to find the most optimal line, that sums to the least amount. Okay, hopefully that's a 5th grade level. Does that kind of make sense, what we're doing here? Okay, let's just do it. Gosh. Right, if it's easy, then just do it. Okay, so in here, I've already prepared some of this. I'm going to model one feature and one response. Okay, in here, we're going to watch as I load. And like I said before, what I like to do is to make sure that I know this is working right, I'm actually going to use their features. But since I'm only using one of them, and we already saw that one of them doesn't really tell much about the feature, I'm going to use that one and create some fake data where my fake data is equal to that feature times some random value and just some noise. Okay. So I'm creating a plot like this using one of their features, but then the response just ran. Okay, so now let's run this and let's get plots going. And dang. And if I call it selected, sweet. So
Do you guys want some sandwiches, by the way? I was just gonna wait a couple minutes until everybody got here. Then
Food's good.
yeah. Let me order some food. You guys want Jimmy John's again?
Like there's free smells.
free smells, yeah. And tell me if we're getting too. Is this too long? Is this still interesting? Or?
This is interesting, and being part of what was going to be the business discussion, I actually see this more applicable to me being the pupil versus.
Okay. Well,
I
it's supposed to be a discussion, so tell me your questions.
So the only thing I have also in the background though, you're completely in our studio, you're running Spark locally, but are you?
We actually haven't touched Spark at all yet.
Okay, yeah.
This is more for demonstration
This is our
purposes.
going directly against the files that they've
Yeah.
given you off of the sheet. Okay.
I mean, how far along is our Spark so far? It's not like, was it 50% there or?
Oh, I don't know. Let's see. I used Spark R about a year ago. What's tricky about it, and what I like more about H2O is the models are a little bit more. Yeah, they're developed in H2O, meaning that in Spark R, what would happen is Spark would send it to R. Each executor would send it locally to its own R,
Yeah.
but they wouldn't really be speaking across all of them. You had to write your own customization to pull it back together and then
Okay.
and
It's
do that
almost like
gather
a
step.
MapReduce.
Yeah, it is.
Because
You just don't have to
you're
reduce it.
sending
It's
it
like,
out.
you have
Yeah,
to-
exactly. Yeah, and so
And it
So-
actually runs like an R session, like it would run a JVM for Java.
Yeah,
It runs
exactly.
a session
On every single one.
vendor.
Yeah.
Gotcha. Huh.
which can be great for certain applications, like if you wanted to run one little tiny test on each one,
Yeah.
right? And then maybe all you gather back are like the p-values, right?
So can you use accumulators? I don't want to make the whole discussion.
Oh yeah, you still can
Okay.
because you're still in Spark.
Okay, so you can
Right.
do it that way, but yeah.
Yeah, and you can bring it back. But say if, for example, you wanted to actually do distributed machine learning, now you need to pass back the model, and now you need to have some type of model aggregator.
Okay.
Um,
So pretty
Yeah,
much stick
right
with
all
Python
that.
is what you're saying.
yeah,
Or Java or whatever.
Or
or
go to
H2O.
H2O.
H2O, yeah, they've been doing, they've been making sure that the algorithms are implemented.
Oh, cool.
So
Yeah.
H2O will distribute and aggregate,
Yes,
Yes.
no issues.
I'll
exactly.
have to look into that.
And the layman, it looks like it's much faster and you can parse more data than you ever could before.
Oh,
That's true with Spark R or any of these really.
Yeah.
And I think that's one of the big things that people are coming up more and more talking about Spark and R. And even the mainstream is talking about R even more because it's giving people that have this data science background and this math background to do all these things so much quicker and easier. When you tried to fight this in Excel or something before, it was
Oh, gosh,
it was terrible.
There's
But now-
there's too many resources.
Right. Now you have these tools right there at your fingertips to do this quickly and easily.
For work. And you can set that up as a rule set. So when there's new data that's coming in, it's basically hitting that rule set.
Yeah, you're creating functions inside just like anything else. I mean, I was really surprised when I was at the PASS Summit, which is the SQL Server Summit, the summit for the SQL Server all time. All they talked about for the SQL Server 2016 that's coming out next year, they've got some releases, is how much they're baking R directly into the product. So it can query and do things behind the scenes. People are using R more and more, even against relational databases, because their data is still there. They just want these types of tools to do it. They don't want to be burdened by the SQL query language to do it. And so now they're giving these directly to it so that it can write.
But your rendering time, I mean, it's completely different.
Yeah, it's completely different. It's not even close.
So
And you could tweak it if you need to too. Come back, run that. People in the commodities markets are going to have a lot of fun with this.
Well, when I did my time in the foreign exchange world, this was a lot of what we talked about a lot. We had predictive engines in there
Yeah.
too that they try to write into there, but that market that's where it truly is, somebody says something in a different country and it can still impact certain things said somewhere else. It's a terrible, terrible market.
But I can see when we can have kind of the questions that we want to ask from an HR standpoint,
Yeah.
and how it can tie into different variables that are going to be different by geography and even to the
Yeah, all those are
age
different
of the
factors.
distance.
Yep.
The ability for you to tweak to be able to get to that linear line of where that data lies is going to be something that will be a difference between a Joab County or something else like that. But you can also see the same type of propensity that's going to be able to work out. It's very, very cool.
What I really like about what you're stressing here on Kaggle too is that it gives you the tools. It starts helping your mind think about those variables and those features and stuff. Because a lot of the times you'll be sitting there doing work and you'll be predicting something, but your 3 variables or whatever that prediction is, and it's not dynamic. You don't have to change it much. You don't have to do anything.
My computer is dying.
Power.
Oh no.
Life expectancy.
Yeah, seriously.
Well, you just disconnected. But anyways, I was saying the Kaggle part of it, that really helps you to learn those other features and stuff. And how we were just thinking about that. That's a great exercise for people just to do. I didn't see those competitions like that, but now I'm thinking more and more about it.
And you're going to see more of what is happening as an omission of a data set
Right.
versus an inclusion.
Yeah.
Which is cool.
The Kaggle basically gives you the ability to go outside your norm, really, is what it is, and help you think about those things more. Because what we're doing, we're thinking about a lot of different variables because we have a lot of different customers and a lot of different types of data. But most people, they're like, well, I've got one set of data and this is all I need to do. And that's kind of what they do it for. So, okay, technical difficulties for a minute.
Yeah, seriously. Where did I put my lid?
Your what?
The lid to the
Oh, the cap to that.
yeah, I just rebooted it. It was dead. So
It's running too much R.
yeah, what I wanted to talk about next, I wanted to get the demo working. Now, hang on. There's more to this also. Oh, this is loading back up. Thank gosh, man.
Just turn your camera on so everybody can see you.
Yeah, I know who it is. No, that's fine. Okay, so the next piece is, so I introduced this, my code was dead, I don't really want to debug it now, but I have code that I'm gonna run at each one of the processes. The next one is we want to predict just the next Y, again, the next, oh, here it is. Is,
There you go. Cool.
yeah, funny. So that's great and all. In a lot of applications, this is all you need to predict is just one variable, right? But like we showed, we need to predict not just what's happening in the next 10 minutes, but so this is 10 or whatever. We also want to predict what's happening the next 20, right? And the next, right, so forth, 30, and the next day, D+1. And each one of these is going to have its own, they're going to be impacted to some degree, M, by those, right? So now this becomes M10, for the 10th one, this is M10 for this 20, for 20 for this one, plus M20 for this X2, right? This is this expansion, and this multivariate process can still be represented in vector representation, where each one of these now, even B, you could just imagine now instead of having M, plus B, you could just have M times X0, where X0 is always equal to 1. Boom, that's your B, right? And B. Boom. So now everything can just be represented in linear algebra, and we can do the same gradient descent on it.
Now, what happens though if it doesn't go down in time per each factor, each feature, each variable, or if there's a progression from the first one going out. So let's say any change in one will also be represented in the second feature, and in the third feature, and in the fourth feature, and so on. So let's say the first thing that changes for that time period then affects all of the other ones, right? That's going to change your equation. It's going to change all of your assumptions too, right? Do you understand what I'm saying?
Yeah, a little bit. So, are you saying like?
So let's say the first feature is how many traders are on a platform, right? Well, then the second, when you get into that next 10-minute increment, if the number of traders that are on right now has changed, it's going to change the rest of the features all the way across.
So like, are you saying so that the next, this one has some dependence on that one?
Yeah, or more than like N20X and has an effect on the next N20X and the next N20X afterwards, or whatever the features may be.
Yeah, there's that too.
So not just so horizontally rather than just this vertical change down, right?
Yeah, you might have some dependencies here. And so forth. And so one way of looking at it would be saying that this y is a function of these,
Right.
and it's also some other function of that one, y10, or that this is a function of that m, right?
Mm-hmm.
And
of any other one along the scale,
right? That component of y10.
Right.
Yeah, absolutely.
And you'd think within stock trading, it's always going to be that way because Janet Yellen says something at 9 o'clock in the morning.
Yeah.
Well, later on, all of the other pundits that are responding back on it are all saying something, and those pundits are now features of what Janet Yellen did originally, which also now has a time lapse on it. So now what she said isn't nearly as important at the end of the day as it was right when she said it at 9 o'clock in the morning, right?
Yeah.
So
I remember the good old days when what the Fed said didn't matter at all. It was like 15 years ago, right?
that's because it came out through a newspaper. So by the time it was relevant, it was irrelevant.
Plus, they didn't drive things as much 15 years ago.
Okay, I'm back up and running.
Okay. Log into Google, hit that,
Well, they didn't-
or use the same Google login. Do you need the password?
No, I
And the
think.
agenda too, right? It's
on.
the same. Hey, everybody.
Oh, yeah, he's back. Okay. We go over to them.
Welcome to Salt Lake City. This is the party area. Since the Fed has come up, let's talk about Fort Knox a little bit. I don't know what Google Hangouts does that. I never took the time to figure out what it's doing. But it's very cool.
I know what it's doing.
What's it doing?
It's sharing it stuff.
Oh, they're sharing the Windows broadcasting.
Yeah, so if Google was really bright, they would stop sharing the desktop. When they say share desktop, they would not share their own window.
Yeah.
That's the problem. If they would not share their own window, they'd be fine. That's the simplicity of what needs to be done.
Okay, well, we're talking about idiosyncrasies and Hangouts. Why doesn't RStudio, the application, show up? You can't, if you try to share, when you try to share, RStudio doesn't show up on the list of things to share.
In Hangouts?
Oh, weird.
Hangouts, at least in Linux. I don't know what
So
Windows.
it's actually probably not RStudio.
I figured.
If you don't have it open and actually open the window, not minimized, you
Right.
cannot share
No,
it
it's
in
open.
Hangouts.
Even when it's open, it's always, it just.
Is it on another monitor?
That could be it.
I don't know.
Although I see things on both monitors. Yeah, I just install.
Hangouts frequently will not share a minimized application.
I'll check that.
If it sees it as minimized, it will not share. We ran into that tons of times.
So it has to be open behind the.
Right, and that's the whole problem is that you say, okay, let's just share one application instead of sharing the desktop and having that tunnel effect. It doesn't work because it's minimized behind the scenes because Google is open.
When I've had times if you have two monitors, if you share the desktop, it would just show one monitor, and I've had other times where it shows both. But I'll try. I just install our Studio Server instead and just show it there. But,
That works.
you know.
Yeah, minimized applications is not happy.
Huh. I just thought it was combination.
I just showed my desktop.
Yeah, the best way to do Hangouts is you share your desktop and minimize as quickly as possible.
So whatever's visible to you is visible.
Yeah.
Okay, so fingers crossed this one's gonna work. Let me just try.
Without it.
I wonder if it's. I don't know why it did that. Well, my code was broken. That's why. Yeah, it's because when I realized that I might want to present this, I started creating all these checkpoints, but I didn't really do it logically at 12:35 p.m. No, I guess that's the middle of the day. Okay, so the gist of this is like that example we were showing. Here we go. Now I have in this plot my cost function, and I'm iteratively looping over each one of the data points and using the current M values and B value to adjust this line. So
That's why the line keeps getting.
yeah, so you'll see the line, it just slowly starts creeping up to the point where it's going to line right underneath all these points, and then that means the cost will have leveled off, and that'll be the best that this algorithm can learn from the feature that was passed in. So in this case, we, again, just like the other one, I am using fake data, and I'm only using one feature, but this time I am predicting 2 Y responses. Okay. Y1 and Y2, 2 different fake data sets. So now let's look at M list. So this is when it ran the 21st time, the very last time. This is all the M values, and you can see that when I created this, the M was 2.5, which it got really close to, and 1.5. Okay, so that means that it, converged for those two variables quite nicely, which is great because it should.
That's probably your guy.
Oh, yeah, I'm sure.
Oh, nice, way fast. Okay, so now. Okay, now
It's not my favorite slogan.
I don't know. I've already gone over 30 minutes. Maybe I should just wrap up what I'm thinking and kind of the use case and what's nice about this.
Now, are you doing the 2 hours here? Or?
Well, I was just going to do one.
Oh, cool.
But
And
it's
is
already gone
there like a Spark component to all this, or did I miss that?
over. No, well, yeah, at the beginning we talked about it. I
Okay.
think you might have missed a little bit of it. But no, I haven't gotten to using Spark yet for this, but that was part of, like we were saying, part of the justification in picking this algorithm, because I knew that it would port nicely to Spark. And MLlib. The other nice thing that I haven't mentioned yet about this is this sweet little gotcha that they have on Kaggle. Okay. So
Thank you.
not only are you trying to predict the future values, but
It's all for us, I guess. You guys can want to-
but they also have a different weight assigned to each one of the predictions. So what that means is how important is it that I get,
yourselves.
how important is it that I get this, day plus one's return right? Well, they have a weight, right? It says, oh, this is very important. It's not very important. A scale from 1 to 100 or whatever. Anyways, that daily weight changes for each one of them, right? And why that's important is that subtle customization
For each one of the stocks.
Yeah, to each one of the stocks. Yeah. Here, let's look at it again. Let's look at head.
That is tricky.
had trained, we have the intraday weight, and see how it's different.
Pretty fast.
We also have the daily weight.
There you go, sir.
Okay.
Huh.
So that's important to know too, because you can't just take an
You
optimization.
can't take it off of the day only. You
Yeah.
have to take it
Yeah.
off the time period that it relates to.
Yeah, there's a little bit of that.
Yeah.
But also, this means that this is not a straightforward optimization problem. You know, you can't just plug it in and just use it. You have to take into account this customization, that there's that weighted value, which is to say, if for example I'm looking at this log, you take any one of these values and remember I said it's the sum of the squares of the differences, but for that point, it's times its weight,
Yeah.
right? Now the other gotcha is, so that's fine and dandy and all if you knew the weights, but they say that the weights can change. So that also tells me that you probably want to predict, or at least take into account, the variation that's possible due to the weights as you're modeling, so that you can imagine, so that if you're given a choice between, oh, should I try to get the intraday value right, or should I try to get the next day value right? Well, if I have a good inclination that the weight is much higher for the intraday, for example, and there's a smaller weight on the next day, then I'll be okay if I'm wrong. I'm more wrong on the next day one, right? I want to focus. I want the algorithm to focus on modeling the ones with the higher weights, right? Anyways, that example of the subtlety is another reason why, what makes gradient descent nice, but also why you need to have an intimate understanding of, the machine learning algorithm that you're using, so you can make that customization and not just attempt to use a black box, right?
On a related note, it seems like if you're doing the iterative approach, right, then the values that you get for those 10-minute intervals will also affect, the
Yeah.
daily intervals. So even if the weights might be higher on the daily ones, if you're off on the 10-minute ones, it might, exponentially vary the weight or the correctness of the two. So it seems like you'd always want to, at least in your algorithm, weight the 10-minute a little bit more.
Oh yeah,
Because
and then you're right, exactly.
because
Kind
you'll
of like
compound.
a logarithmic or some kind of weighting that gives greater influence to the more recent ones.
Although, if you do that, the smaller increments are always going to be more volatile, right? And so your longer tails on the days, you could start saying, hey, we're having this huge upward trend right now, and your day could end up having much higher.
Oh yeah, in kind of like a momentum sense, it could push it a lot higher than it should be.
For what a day would be.
Yeah, these are types of things that you have to. This is actually kind of where, in my mind, data science, it makes this progression. You learn the mechanics, right? Like how to type, how to use Python, how to use RStudio. Those are mechanics. IPython notebook, how to fire up a cluster. But then you also need to learn the fundamentals, which are like statistics, linear algebra, like order of operations, stuff like that. There's fundamentals. But then you get into like the art, right? And maybe people call it science, but the art of it is now you have to start kind of relying on knowledge from other domains, or, just start putting in your 10,000 hours, and you just kind of get the feel for what should work.
Understanding the why and massive.
Yeah. And
You're-
sometimes
you're,
it's hard to explain.
You're exposing a level of modeling, though, that couldn't exist before this methodology in business modeling. Because typically it takes so long to run your queries and to come back with your information that what you might have needed to be able to tweak and mean was no longer applicable.
Oh yeah.
It just completely changes the rule set.
Yeah, it's a different approach.
Doing it from empirical data, to doing it really in a live fire environment, right?
Yeah, created an OLAP queue to do this. And 18 months from now, realize that you forgot something.
Yeah.
And go back and try to
Change it.
Yeah, and then
change the whole
yeah,
thing.
exactly. And then some things are hard coded or or whatever.
Well, and no one on the planet wants to write MDX to do that. I know the few people that have it and they don't like it.
So so what I've shown you so far is actually pretty simplistic. The very next thing is to take into account things like the weights and so forth, and then and other optimization criteria, and apply it to all features and all responses. And even this, I'm only doing 2 features and 2 responses in a. Yeah, this one's still fake data. Okay. And this, shoot, new 2. I don't know what I was doing. Oh, right. Yeah, I took snapshots at different places. So, okay, so now imagine, basically we've blown out that equation. So if we get here into the guts of this particular algorithm, you loop over each observation, which is each data point, right? Each new article, or in this case, each new stock, each row, right? Each 5-day observation. And you take into account that model's, that individual point's contribution to the gradient at that location to say, given what I'm seeing here, how do I need to change? Where do I need to take my next step so that I can minimize my total error, my total cost, right? And what's neat about this too is because we're using such a large sample size of up to 40,000, I can actually just kind of take sample observations of what's happening around me and get still enough information to know I need to move. I only need to measure so many points to know I need to take a step in that direction, which is great. That's a great way to tweak it and make it go faster. Anyways, but so it runs this matrix multiplication, updates the new M, appends that to the list, and then finds the new prediction values using that new M matrix and so forth. Okay, but another neat thing that I can do, in addition to tweaking it so that I can handle the weights appropriately, I can also apply a second step that, say for example, I want to know which direction I should move in, but I want to apply another criteria, say for example, if for example all of my values needed to be positive, all my responses need to be positive. Well, I could just take care of that right here and just say, take the next step in that direction. Oh, but as soon as you take that step, move, sidestep a little bit so that everything's positive, So it's always like slapping me as I start to butt up against that boundary criteria, that optimization criteria. So that's one example. Another is maybe I want to bound the in a data sense, I want to bound the responses over time, right? Like why? So every 10-minute interval, maybe I only want the next 10 minute to be not more than twice the one before it, or something. Like
Some variability.
yeah, some variability, and associate and tie them together. I can also do something like that and apply additional criteria so that as I'm iteratively moving, I keep slapping it, or I keep it in check, basically.
So tell me, is it keeping it in check, or is it that like the positivity of the student? So let's say you were talking about distance, right? You're not going to want to have distance become a negative.
Yeah.
And so when it's keeping it in check, is it actually just moving 0 so that you say,
Yeah,
it looked like -1 originally, but now it's actually +1 because 0 has moved down?
No, it's probably. I mean, you can decide what your constraint looks like, but in distance, I would probably just take all the negatives and move them up to 0, and then so literally you would be like walking on that edge when it applied.
And that also keeps your tail really close to
Yeah.
that 0 is.
And while the algorithm might be saying no, to get the best cost decrease, you need to take a step in the gradient in that direction. Well, then I come in and say, hey, there's a cliff there. You can't. So then it'll keep wanting to move that direction, and it'll never get as low as, mathematically it wouldn't get as low as it could, but it still is going to keep moving lower, but staying where it should. Right.
So now it might become 0.75, 0.5, 0.25.
Exactly. Yeah. Okay. So, so why this isn't working is because one of the next pieces to think about, and the real pain of this problem is that these features are. Wow, my code is just a mess. Take these features, for example. We have some that are very large, like feature 7 in the thousands, and then we have some that are less than 1, or with some ratios, right? So the problem here is if I take this data as is and I put it into the gradient descent, after accounting for all the missing values, what it's going to want to do, just like the weights, it's going to want to first take the learning that it can from the largest numbers and deal with those first, right? Because those are the ones that, I mean, you just threw a boulder at me. How do I handle what that means, to this observation? Well, there's all these other pebbles, but that's not really the case. That it's just that the scale happened to be really big. It's not that really was a boulder, because it might be those small pebbles are telling you something. So what you have to do first is normalize this and normalize all of your variables so that they are on a consistent scale, so that when in this particular algorithm it can treat all of them equally, right? And it doesn't take one feature, and just because that feature ranges in the thousands and another one is some 0.1, say for example the change from 0.1 to 0.2, that should have as much impact on the model as a change from 1,000 to 2,000, right? That's what I'm talking about, normalization.
Wouldn't the algorithm do that automatically by just adjusting the coefficient?
Yeah, it would, but because of the cost, it's going to first change the coefficients of the large ones.
Okay.
Because the way
So
that it's finding the
it'll fit
derivative,
those first.
yeah.
Okay.
And so, which sometimes you might want, and that's the whole point of weighting, right? You might want to say, oh, I have greater confidence in this feature. I know that it was classified right, manually, and I just trust those people or something, right? But in this case, we don't know. It'd be best just to normalize it up front and then let the algorithm just treat them equally. But you're right. If for example, in the gradient descent, it's basically going to move in the steepest descent. It's going to decide what's steepest partially because of the weights, but also because of change in that direction gives you the greatest decrease in cost. Getting more less error. Anyways, but so what's going to happen is the algorithm's going to race down the hill on the really big values, and then once it finds optimization there, then it'll kind of like putter along down the smaller one. So you're right, it would get it eventually, but in this case, I want to equally weight them so that it kind of moves, and solves them all at once.
And we don't know if these features even relate to each other in any shape or form. So like one may be industry, another one may be
Totally, yeah.
money.
Yeah, and unless you tweak it with what you find intuitive, you might miss out on something that's like a butterfly effect.
Oh yeah, of course.
Smaller values.
Yeah. So that that exactly is why I would go back to my textbook and do some money.
Sorry.
Yeah, now what you're talking about is this, like dimensionality reduction and really, feature feature analysis. And just understanding what the relationships are. If there's any compounding effects, but the thing is too, you can just generate all of them. All like pairwise interaction effects.
They'll take away
2 and 3 levels deep or whatever. Yeah. And you can try all, logarithmic and squares and, whatever you want. And then basically instead of having 25 X's, then you have 25 times squared, basically to get all interaction effects and then pairwise. And then you can just keep going wild, and basically do feature engineering to create all of them.
So this might derail us a little bit, but this may actually be an answer to it directly. Is there a way to kind of give categories to the things that you can do within machine learning? Like problems supervised in the classroom. Would those be overall categories where you could say, I'm going to fit sentiment analysis into clustering. I'm going to fit, because you could take sentiment analysis and you could put that into a supervised learning situation. You could there's a way to boil use cases down into different categories.
Yeah.
Right?
Oh, absolutely. But these are more classified based on what you're trying to model.
Yeah.
Right.
So you could get a big list of use cases and do that yourself and figure it out. But in other words, the machine learning libraries, it doesn't sound like they're geared that way anyway.
Yeah.
Because they could be used in different ways. You could use clustering in one, and then you can use it for another one.
Well, so the reason I ask is it's related to business. If you as either a business owner or as the person solving the problems for the business could say, here are the 10 different types of problems that we could solve. Here are 10 different categories. Let's go through them and figure out where there's business value for us, right?
Yeah. That is exactly touching back on looping back to the very beginning when I was talking about my data, my video, my auto analysis. So I'm kind of flipping this and saying, I don't necessarily know what you're trying to solve, but I know what you're giving me, or I have an idea. I can tell that it's categorical. I can tell you've got, and different things in there. And I might even be able to extract that, you have company, you have stock data, or, what you're giving me. But without much domain expertise, I want to just tell you what the data wants to say, right? At the end, you might be like, well, I didn't really care about, knowing that, the Apple has dropped 10% in the last month.
Right.
But what I do care is that, Apple and Microsoft are a part of the, just a segment that's, or whatever, so
I it was red, but it's actually
but for some people that might be information that they care about, but so that's where it's a little bit tricky, but you bring up a good point. That's kind of cool. Anyways, that's shoot. I don't know, probably a good stopping spot for now, but I think for next time what you can expect and what would be really fun is to take this work that we've done so far and move it all the way to the generalization step of applying it to all the features and all the responses, and doing so on Spark or H2O in a distributed fashion so that we can solve this in a reasonable amount of time versus in R, while this reasonably fits in memory, it's no big deal actually. It's going to be very slow to solve for all 25.
Other questions?
Or thoughts?
If you're doing this whole set in H2O, how would you be trying to set that up? I mean, like how many Would you be running clusters? What would you be doing to solve a problem like this?
So when I do, actually, so I haven't looked at H2O. So we pulled up,
Or Spark or whatever
Yeah,
you would use.
we pulled up Spark. So, so this is what it looks like at home. This is what I have. I have my Spark clusters, and I said that I have eight individual commodity machines with at most, or on average, 16 gigs.
Of RAM?
Of RAM, yeah. And then, which isn't a big deal for this problem, right? It's actually going to be more the CPU that I'm using for this, the distributed CPUs. And then what I'll use is right. So what you're asking is what's the distributable part of this, and there's a couple ways that you can distribute. One is by distributing the k-fold process, which is that I'll want to model just a portion of the data, but do that independently, model each one of them, and then just make sure that I'm converging right at something that is consistent, and that I'm not overfitting to my training data set. So that's one thing. I could just distribute across 10 machines, run them, so forth.
Yeah.
But I can also take a stochastic approach, and yeah, please. And I can take my best location, or my best my M matrix, right? My best model, send it out to all of them, and let them start there and move forward. And then after some iterations, come back and say, okay, now who did the best, right? In a stochastic sense, they may have, they were using different parts of the data to move forward, but then I can merge that and make that my new starting spot, rebroadcast, and keep progressing forward. And honestly, I don't know exactly the default what their approach is in H2O or in Spark that we pulled up, but that's I guess that's part of the grit, right? Hang on, let's see if there's an article. So I'm not even seeing the, here we go, documentation. So, so this is, exactly what it looks like in R. I would put this command in to my RStudio, yeah. And this is going to load the H2O package, and it's going to connect to the server, and there we go. Connects. So this one's just local. It creates a local instance, but you could connect to the server, and then in this case, it's just running the k-means demo, right? And in a similar sense, while I mean that's overly simplified, I can do the same approach and pass in all of my data and the data actually could reside on the servers, but this is a relatively small data, so I can just pass it with it. But I can also, and then I can pass in all the parameters, my optimization tweaks into the gradient descent. So, I mean, I'd assume they have like gradient descent already because we saw that Spark has theirs. Let's see. K-means. Oh, here we go. GLM. So I'd assume somewhere they expose the like bare bones of gradient descent, but I could use
The general.
just basically use the parameters, to define the GLM and do Gaussian regression. And then under the hood, it's going to handle all the distribution, you know, and then basically send that to my RStudio console. The outputs, the cost and or maybe not the cost, but it probably will. But certainly the final output, the model, you know.
Yeah.
But that's that's for next time. I think that would be a really fun follow up. That and really putting it head to head against some of the other. You know, I kind of steered us down that direction, but there's certainly other, like naive Bayes, that we could explore, and compare head to head, or like if we're in a forest, or.
Has someone already solved this one, Kevin? Or is it just that continuous?
This one ends. There's a leaderboard.
And it's not a solved one, it's who gets the most.
Closest to the, that's right. I'm just wondering if it's a closed competition, because I assume you can still go back and do that. I mean, if they're close, I'm just wondering if it's over. Right.
So this one kind of, you can see there's some very frustrated people who are assigning their team name. Anyways, what happened was they realized a mistake in the way that they presented the problem, that there was a really easy solution that gave people high accuracy, but it was but it wasn't the approach that they wanted, wasn't getting the right response from the community. So they changed that at the beginning of last week, and as you can see, we only have a month left, and so there's various people that are pretty pissed.
Does this sound right?
Yeah. I think it's fair. I don't know. Yeah, whatever.
Wasn't that how you won the first one?
No, that was a joke. Yeah, that was.
Well, that was Ben's.
That was been.
I don't know. Right?
Presentation. So I wanted to take just a couple of, since we're out of time right now, and talk about business real quick, because I think all of this stuff is really cool. And there's a lot of great things about it. And like with Canada, they're a perfect example for me of a situation where you can have somebody be the best of the best on there, and it doesn't mean that has any kind of reality to value to it, right? In fact, if you look at like the top 3 people, all day long, I would hire the person who is third place over the people who are anywhere else, because the person who's first has like 135 competitions under their belt, and although they've scored really high on a lot of them, it's the fact that they have 135 versus the person who's third has like 32 competitions and is right there, right? So let's talk about value for just a second, because no matter how accurate you get, no matter how good your validations are, even if you create the best solution in data science, if people understand the value, it doesn't matter. What's the most amazing thing you've ever eaten in your entire life? And do you remember the scenario around it? So for me, I consider myself kind of a foodie, and I've eaten everywhere I've traveled. I've had really unique, really good job here, right?
High quality.
Yeah. But the most amazing thing I've ever had was when I was starving, and there was some chicken broth and some roll that was really a dry, nasty roll, but nothing has ever tasted as good in my life. It was the only thing I had to eat. It was the only way I could eat, and I'd been without food for a long time, right? So my perceived value had changed drastically. It wasn't about the quality of the food. It was no longer about the availability of like the time period, like how quick it got to me or anything else. It was the fact that there was food there that I could eat. And that was amazing, right? And so when we talk about like a project like yours and anything else, we need to think like, do we need to create the world's best steak or not? Does the world's best and most profitable steakhouse actually compare in total profits to what McDonald's makes or to what Walmart makes on their food?
per transaction.
Maybe not. Per transaction, yeah, absolutely. And that's actually the point I want to get to, is that it's about not only that perceived value, but the number of transactions that you have as well, right?
Mhm.
We've talked about this concept before, right? The starving food, like I can't create somebody starving at any given point in time, right? Sometimes I can create fads, I can create things that people are going to be really excited about. Creating the video might actually help create that, right? You might get people to start experiencing data science in a different way that makes it so much more consumable than it's been for them in the past, that now you can mass produce that, right? But either way, we need to be thinking about what our perceived value is, what it is that we're really providing, and how we can get as many people as possible using that so that we can increase our income and our revenue. Those are the only things that really add up or that matter when it comes to income and revenue. Is do you have a perceived value, and how many users are going to pay for it? Because even if your product's worth $10 million, if only one person buys it, 10 million is the max you're going to make. Not that that's not a good number, right? But on the other hand, if you have something that's worth $5, but you sell it to 7 billion people, you're going to make more, right? Now, don't cheapen your product just to do that, but make sure that you're thinking in your lives, in your businesses, in your consulting gigs, in your employee positions. How do I create the highest amount of value I possibly can while still making sure I get to as many users as possible? Because the more people that consume my product, the more money I'm going to make. So anyway, I'm going to show you guys this real quick. You asked me to do a one-page version.
Oh yeah.
Can I steal that?
And super quick on what you just said, it's funny how the stock market's like that, because everybody's, especially for in the mining sector, everyone's that one score, or, that, 10 bagger or whatever, right? It's like, if you just make 10 or 20% per trade, in the long run, you're building a better track record, a better business.
Still a bigger, better deal.
And make,
In the long run, oh, the 10 baggers nice too, but
right?
you're ready to lose everything, right?
No, if you can find a way to be able to.
The Big Short wouldn't have been bad either.